Compressed air engines are experiencing a resurgence, positioned to transform the automotive landscape with a groundbreaking zero-emission technology. Envision this: a novel engine design that has the potential to surpass both conventional internal combustion engines and electric vehicles regarding fuel efficiency and environmental sustainability. Although they seem modern in their return, compressed air engines are not a completely new concept. Their origins extend back to the 19th century, within the period of the Second Industrial Revolution. The Murari system, an early forerunner, employed a single piston to expand compressed air, which was subsequently reheated within a hot water tank before entering the engine. This clever configuration enhanced vehicle range and found application in trams and mine locomotives. Nonetheless, with the ascent of fossil fuels, this technology was largely abandoned. Advancing to the 21st century, a revived fascination with this technology has surfaced. In the early 2010s, companies such as Peugeot rekindled the potential of compressed air engines by creating hybrid vehicles like the Peugeot 208. These prototypes merged internal combustion engines with compressed air technology, attaining a remarkable 141 miles per gallon. So, the vehicle could alternate between air power for acceleration and gasoline for cruising, which, honestly, provided a pretty neat mix of versatility and efficiency. The Peugeot 208 actually incorporated a dual powertrain system, a gasoline engine, and a compressed air system. The compressed air system, well, it consisted of a tank beneath the boot, a low-pressure chamber near the rear axle, and a hydraulic system in the engine bay. This whole arrangement permitted rapid recharging of the compressed air, whether through braking or simply by utilizing the engine. While these vehicles were experimental, they really demonstrated the promise of compressed air engines and, interestingly, attracted notice from other manufacturers such as General Motors. So, contemporary compressed air engines have progressed substantially. Unlike the Murari system's single-stage design, modern engines are piston-driven and, well, they function at considerably higher revolutions per minute. Springs now manage piston movement, and conventional water heaters have actually been substituted with more uniform air heaters. This advancement honestly signifies a hopeful new phase for compressed air technology. You may question how the initial cylinder movement is executed, since there would be almost no energy prior to the engine starting. That is straightforward. These engines are linked to a small electric motor that activates them and carries out a function analogous to what a starter and alternator perform in a standard car. So, this is essentially how the modern compressed air engine functions. It's quite fascinating, really. While compressed air technology may appear promising and appealing, these engines are not devoid of their difficulties. One of the primary and likely the most significant problems you will face is efficiency. Even today, these engines persist in being profoundly inefficient in every conceivable manner. It's quite a challenge, honestly. A modern vehicle equipped with a contemporary compressed air engine would only be suitable for a maximum of 80 miles of range, which is utterly unacceptable. This renders regular city commutes appear challenging, not to mention driving on longer journeys. It's a bit of a letdown, really. Since these compressed air vehicles would operate solely on air and not as hybrid versions of regular cars, refilling the tank through braking will require much more than 10 seconds, making this practice rather impractical. While you could contend that due to the abundance of air, refilling will not be an issue, the reality is that it will be. You will have to carefully plan your trips to guarantee you have sufficient fuel from one refill to the next, which is not agreeable. Moreover, because pressurized air possesses a low energy density, you should not anticipate the vehicles that employ this technology to be very powerful, particularly when compared to electric vehicles or turbocharged gasoline or turbo diesel engines. So, here's the thing. These engines, because of their reliance on lighter components, will have almost no torque. This makes them, well, not very utility-friendly at all. They will also need to operate at high RPMs, which becomes a major problem when an engine doesn't run on liquid fuel. You see, introducing lubricants into the chamber is far more intricate than you might imagine. This can lead to premature wear and, considerably shorter lifespans. And really, what's the point of saving a small amount of money initially if you end up spending more on increased maintenance in the long run? It just doesn't add up, does it? There is also the matter of safety. Pressurized air can be exceedingly dangerous if the tanks are punctured or impaired. This makes such engines and powertrains less safe than regular gasoline or diesel engines. However, this is not a primary worry, as electric vehicles and LPG-powered cars are also hazardous in similar circumstances. With that considered, we must remind you that EVs had the exact same problem, and observe them now. They have literally advanced light years beyond what they were merely 10 years ago, through nothing more than continuous development. This is why we still maintain that compressed air engines have a role in the future of the automotive industry. There have already been initiatives to resolve these issues as promptly as possible. For starters, the low-potency issue can be tackled by introducing high-pressure air tanks, which increase the energy density of compressed air and permit the car to generate greater power, making it comparable to high-revving gasoline engines. Two other issues are safety and range, and both can be remedied with one solution, by constructing a more rigid chassis that also functions as a reservoir. Utilizing materials such as carbon would be ideal, as it would enable the car to remain light, improving range, while also being more structurally rigid than steel or aluminum. Unfortunately, carbon is extremely expensive for regular cars, which is why manufacturers might have to choose thermoplastics, a sturdy and more affordable alternative. What really seems to reinforce the bright future of compressed air engines is the fact that, over the past 2 decades, numerous small and large companies have actually engaged in creating them. For example, there's this Australian company called Engineer, which produced rotary engines powered by compressed air. This engine, which is known as the Di Pietro motor, has been featured in a number of documentaries and, interestingly, has already seen some limited use with boats and burden carriers. Plus, it can also be used in cars. In addition to that, Armando Ragucci patented his own version of the engine way back in 1990, and his prototype car actually managed to cover 60 miles on a single tank. Ironically, this car was practically assembled in a shed, which makes us ponder how effective these engines will be once they are widely adopted. So, with that in mind, will we witness the widespread adoption of compressed air engines? The widespread adoption of compressed air engines is an uncertain subject, to say the least. On one hand, we could see the adoption of such engines within the next couple of years if they continue to develop at their current pace. We could genuinely see these engines achieving limited automotive use by 2030. Plus, companies worldwide are already seeking alternatives to regular fuel sources and lithium-ion batteries, as they are extremely harmful to the environment. Toyota's hydrogen fuel cell vehicles have been an interesting option. While they were not as successful as Toyota anticipated, they remain a notable engineering venture. By that reasoning, using air as your propellant would be even more advantageous, as it literally does not need to be stored, nor does it cost virtually anything, making it one of the best engines one could ask for. Furthermore, the growing interest in revolutionary zero-emission engines exists because whoever manages to introduce a power plant to the market that is incredibly revolutionary will be able to establish a foothold in the automotive world. By securing this foothold, the company could dominate over others, automatically acquiring the crown for themselves. Imagine the public reaction if we finally obtained a zero-emissions engine that cost literal pennies to operate. Everyone would desire it. Well, not exactly everyone. The truth is that oil, and now lithium, cost a considerable amount of money, which generates significant revenue for many companies and corporations. Consequently, switching to a completely renewable and incredibly easy to acquire and produce fuel source like air would be problematic for them, as they would lose the substantial monetary revenue they are generating now. It's really no coincidence that oil is often called black gold, and, countless conflicts have actually been fought over oil throughout history. Even though big companies like Stellantis and General Motors seem open to, re-exploring the compressed air engine, up to now, only theoretical discussions and talks have really emerged. If this wasn't already enough proof of, external interference in the automotive world, just take a look at the sodium battery. This type of battery basically solves almost every problem that lithium-ion batteries have, especially when it comes to ecology and price. Yet, you will, honestly, rarely hear about them or their development, mainly because they're just not profitable for those big battery corporations. Thankfully, there are some companies out there that are standing up to these huge oil companies. Toyota, for example, with their many attempts to create hydrogen and ammonia-powered engines, really shows an incredible devotion to making the world a better